Hey guys, my name's Lindsay and today we're going to take a look at a little bit of basic algebra. And a quick definition for you of algebra. Basically, algebra is dealing with math, numbers, like we are used to, but now we're going to add some letters in. So the definition of algebra is really just math dealing with letters. So we're going to take a look at a few examples that you can see floating above my head here. And for all of these examples, we're going to solve for x. So really, all we're going to do is figure out what x needs to be to make these statements, or y, or m, to make these statements true. And maybe you could look at the first one we have here and figure that out pretty quickly because it's pretty straightforward, but as we move on, these techniques will probably be kind of handy. So let's take a look at this one first. We've got x plus 4 equals 13. So what we want to do for all of these questions is we want to isolate the variable, the letter, in this case x. We want to get it by itself. So what I need to do is I need to get this 4 away from the x. And since the x and the 4 are separated by this plus sign here, they're not attached to each other, all I need to do is move the 4 to the other side. So x stays on the left of the equal sign, 13 stays on the right, and this 4 is going to the other side. But since there's a plus sign there and we've crossed over an equal sign, we actually have to flip the sign. So now it's a negative sign. I've got x equals 13 subtract 4, and 13 subtract 4 is 9. So that's a pretty straightforward example. Let's take a look at another one. We've got a second example here, 2y subtract 1 equals 21. Now this one has got two things going on. The first thing that we need to do in order to get this y by itself is to get rid of that negative 1 from the left side of the equal sign. And we now know from over here that we can move that negative 1 from the left side to the right side by changing its sign. So 2y, 21 plus 1, 22. But now I've got a 2 stuck to that y, and I can't just move it to the other side because there's no plus or minus sign in between the two. They're stuck together. So the only way to get rid of that 2 stuck to the y is to divide by 2. It's going to let us cancel those out. But if we do something to one side of an equal sign, we've got to do the same to the other. So I'm going to divide the other side by 2 as well. So these questions are always going to be that we're going to divide both sides by whatever's stuck to your variable. We do that because 2 divided by 2 is 1. They disappear. So I've just got a y there. And then 22 divided by 2 is 11. Last one we're going to do on this screen. Now we're dealing with a fraction, and fractions can be difficult to deal with. So what I want to do is I want to get rid of that fraction. There's more than one way to do this. As in all math, there's often more than one way to do things. The way that I think is the most straightforward is if I've got a fraction on one side of the equal sign, I want to make a fraction on the other side. And if I want to make a whole number into a fraction, I'm just going to put it over 1. So that's what I did. I've got m over 7 equals 5 over 1. And the reason that I did that is because now, I'm going to put a little star here and write it for you, I can cross multiply this. So I'm going to cross multiply these two. And what that means is I'm going to take the m on the top and I'm going to multiply it by that 1 on the bottom. 1 times m is m. And then I'm going to take this 7 on the bottom and I'm going to multiply that by the 5 on the top and I get 35. And all of a sudden our fractions are gone and we actually have our final answer there. So I'm going to just make some quick space and then let's look at a question that's got a few pieces to it. All right, guys, I'm back. A little bit of work cleaning that board off, but it's clear now. Let's take a look at one more example. And it's got a couple pieces to it, and one thing we haven't seen before, and that's that squared sign up there. So again, the point of this question is to solve for x. I want to know what x should equal to make this statement true, but I got to get x by itself. And I can't move this one over or divide the 5 out until I deal with that squared on the outside. And the only way to get rid of a squared is to put a square root sign over that whole thing. The reason that we do that is because the square root sign and the squared will cancel each other out, and we're left with 5x plus 1. But if we do something to one side of an equal sign, we need to do the same to the other side. So I'm going to take the square root of 121. which is 11. So I've got 5x plus 1 equals 11. Now I can do what I did in my last example. I'm going to move the 1 to the other side. It becomes negative. 11 subtract 1 is 10. And then again, what I did in my last question, divide both sides by whatever's stuck to the x. In this case, it's a 5. And I've got x equals 2 as a final answer. And what I'd like to do quickly now is just do a quick check. It's not something we did for our other questions, but you could have done it for, you could do it for any question. I'm going to do this in a different color for you. Basically, all a check is I'm going to rewrite the question as it was given to me originally. So this 5x plus 1, and that whole thing is squared, equals 121. And now I'm going to take my answer, that 2, and I am going to plug 2 in wherever I see an x. So the only x I see is right there. So I'm going to plug a 2 in. I'm going to put square brackets just to make this a little clearer. And when I plug the 2 in, I'm going to put brackets around it because 5x really means 5 times x. So 5 times 2 plus 1. And then we'll close that. Equals 121. Now let's solve this. We're now following BEDMAS. We're going to do inside of the brackets first. So we're going to do 5 times 2, which is 10. And then we're going to add our 1, following BEDMAS. So we're getting 11. Squared is still there. And then 11 squared is 121. Now, it doesn't matter what this number is at the end. What matters is that my left side is equal to my right side. As long as those two numbers are the same, I know I'm right.